arrays, data types, strings. You have learned all you need to know to build any app you can imagine. So for these first 2 weeks, we'll be doing fundamentals. Then as I posted on the group, I'll set an exam on Friday. I'll set an exam on Friday to see how far you all are gone in learning this thing. So yeah, I'll share my screen so that you see the PDF. So we are going to continue on our next topic. So, wait. Okay, so we spoke about objects, mutability, strings and their properties, rest parameters. So we are going to continue with higher order functions today. Higher order functions. So basically, a large program is a costly program, not just because of the time it takes to build. With size, you always have complexity. That's why the goal of every programmer is to get the job done in as few lines of code as possible. Because when you have a large program, maybe you have two apps doing the same thing. One was written in 300 lines of code. The other was written in 400 lines of code. The one with 300 lines of code is better because, number one, it will most likely be faster. It will be less complex, so it will be easier to understand. And then finally, it's less prone to errors because it's easier to debug 300 lines of code than 400 lines of code. So looking at this function now, looking at this program, we set a total variable to equal 0 and a count variable to equal 1. So basically, we want to sum all the numbers between 1 and 10. So what that happens is that we'll add the total to the count. So if the count is 1, we'll say 1 plus 0. When count becomes 2, it will now become 1 plus 2. That will be 3. Then when count becomes 3, that becomes what? 3 plus 2, which is what? 5, like that. Then you now see the second one. This one contains 6 lines of code. Contains 6 lines of code. 1, 2, 3, 4, 5, 6. But this one contains how many lines of code? Just 1 line of code. So this one is much more better than the other one. So the truth is that it's the first one that is more likely to contain a bug. And you can see with that one, the second one is more correct. So there's a concept in programming and computer science in general called abstractions. So abstraction is a case where you can exclude internal implementation details and talk about problems at a higher level. For instance, we are all learning JavaScript. Once upon a time, the programmers of the early days, we are talking 50s, 60s, 70s, 80s, 90s. They didn't have all this abstraction where they can just open a text editor. You can imagine those days, programmers needed to know the laptop, the computers we use today, not the computers they used back then. They would have to assemble the parts, sometimes even build up a computer from scratch. They have not even started coding or doing anything proper. They're just building it up from scratch. Or maybe earlier days when you needed to know how you store your own memory. I'm sure a lot of you have heard about punch cards before. You have learned about punch cards in school, right? Punch cards, where you needed to fill in ones and zeros inside cards.
Yeah.
Good. So we thought that was programming too. But now what happens is that we have this abstraction where we've hide the implementation details and talk about problems at a higher level. So you now look at an abstraction is a very important concept to understand. Abstraction basically means that someone has already done the implementation details. So you just talk about it, you just solve the problem at the higher level. A very good example of that abstraction is the built-in functions you have in JavaScript, like console.log. Imagine the task was to print your name to the console. You know, in one line, you just write what? Console.log, my name is so and so. But imagine if you had to write the console.log function from scratch. Remember, we have been doing user-defined functions. How much time that will take us compared to the console.log one? So you can see two recipes for pea soup, where one is like put 1 cup of dried peas, add water, leave the peas in the water for at least 12 hours. So you can see. Then this is the second one. This second one is the same recipe, but it's shorter and what easier to what interpret. And the thing about abstraction is that it's not just about making it shorter and easier to interpret, but it also has to hide a lot of the jargon, the grammar that has to do with building it from the ground up. So you can go into it. You don't need to know operating systems at a deep level. You don't need to know all these things at a deep level. You just know, okay, ultimately, I need to have a lot of RAM so that my computer will not be slow, that kind of thing. So abstraction is used to avoid repetitions too. That is why we write functions. Are you getting me? That is why we write functions, to repeat, so as reusable blocks of code that we can call what? Anywhere. Because writing the code every time from scratch, look at these two examples. This one, I'll have to write the for loop to print I 10 times. But this one, I just have to write this function once. Then anytime I need to repeat a number of times, I just call this function like so. I just call this function and I just call this function, and by the time I'm working with the function now, by the time I'm working with the function, I don't need to write it again. So I can just say what? Repeat log and I want to repeat the number maybe 4 times. Then I run my code. Then I see 0, 1, 2, 3 undefined. Okay, so I can see an error with that code now. Let's try that again. It's meant to start at 1, not 0. So you can see what is going on here. Instead of writing the for loop from scratch at every point in time. So that's just the illustration I wanted to give you. So we'll continue in the PDF. Then you can now see not only about logging the numbers, you can also do actions in the listing. So there are functions that operate on other functions, functions that call other functions, either by taking them as arguments or by returning them. So you can imagine a function as a reusable block of code, calling or taking what other functions. Those are called what higher order functions. Since that we have seen that functions are not regular values, there is nothing remarkable about the fact that such functions exist, that a function can take another function, work on that function, and produce an output. The term comes from mathematics. Remember, a function is just mainly about taking input and returning output. So higher order functions allow us to abstract over actions. For example, we have functions that can create new functions. In this case now, we are writing a function greater than, that returns m, such that m is greater than n. So if m is greater than n, we'll now return true, else we return false. For example, we have let greater than 10 equals to greater than, then we pass in n as 10. So if we now call greater than 10 on 11, that now gives us true. Is everybody following me?
Yes.
Let me even see who are the participants. I want to ask a question. Deborah, please unmute yourself. I want to ask you a question. If this number was 9 instead of 10, what would this console.log give us? Deborah. Can anybody answer the question? If this number was 9 instead of 10, what would this console.log give us? Nobody can answer. It will give us false, because 9 is not greater than 11. It will give us true, because 11 is still greater than 9. So we can have functions that change other functions. So now in this case, if we say a function noisy that takes in a set of arguments, let's say use the spread operator. So any kind of argument, whether arrays or objects, it just unpacks them. It now says console.log calling with arguments. So let result is equal to f of args. So this noisy will now take another function with the parameters what f. It now says the result should be f, calling that args argument, calling with the args argument. So if we now console.log called with args returned result, we will now see the difference between this one and this one. So let's just copy that and paste. So yeah, this is the code. So we now see a function noisy that takes in any argument. In this case, the argument is what? 3, 2, and 1. So it's going to return these arguments such that you log the argument first, then you call the function on the argument. So this function calls this function that calls this argument. So here we now see noise is calling which function? Math.min. So by the time we now run this code, noise is acting as a higher order function. And you now see the output. You now see calling with what? The arguments are what? 3, 2, and 1, which is here. Calling with the arguments 3, 2, 1. Then we now say result should be what? F of args. So in this case, math.min of what? These arguments. These arguments are now represented as arrays. So you now say called with args. So these are the args, returned the results. So math.min of f.args will now give you what? 1. Then you now return the result, which is what? 1. Nathan, if instead of math.min we say math.max, what would this give us? What would the output be?
It will give us 3.
Yeah, calling with 3, 2, 1, called with 3, 2, 1, returned what?
3.
3. So you see noise is taking another function, math.what? Max. Same thing for almost all the other math functions. If we say math.min, it will probably give us what? 2 probably. 3 plus 2 plus 1 is 6. 6 over 3 is 2. So yeah, it's very crucial to understand. Let me continue sharing on you. Listen. We can even write functions that provide new types of control flow. So we have a function unless, test, and then. So this test probably is a Boolean, and this then is the other function. So if there's no test, then you should run this then function. So you now say call another function, repeat, probably that repeat function we said, so to repeat 3 times, where we'll now have what? N, a number. We'll now have another function, N, that calls the unless. So it will now be like unless 3 is, so this is the test now. This is the test. It will now say unless n is an odd number, you should console.log what n is what? Even. So it now starts from 0. it repeats this 3 times. So it will start from 0, go to 1, and go to 2. So it will now say 0 an odd number. No. So it will now print 0 is even. Is 1 an odd number? Yes, nothing will happen. Is 2 an odd number? No. Not yes, it will print 2 is even. Like that. 0, 1, and what? 2. So if it fails the test, it now performs what? This function. Remember arrow functions, how I taught you how to write arrow functions, right? This is an arrow function, an unnamed arrow function, where you can see there's no name. So there is even a built-in array method for each that provides something like a for off loop as the higher order function. So it takes an array and performs a set of combination functionality on them. Let's look at this for each in detail because it's the first higher function that you have to learn. So let me share my screen to the VS Code. So we have this for each. Then it takes the first parameter. This first parameter is the element in each what? Iteration. Here, L is represented as what? Element. So in the first case, L will be what? A. In the second case, L will be what? B. Then it console.logs what? Each element. So it performs a function for each element. I mean, that is why it's named for each. So by the time we now run the code, what it's giving us for each is not defined. Let's run the code again.
Hello, is anyone there? Is it just me or the whole network?
Hello guys, can you hear me?
Sorry, I had a bit of network issues. Let's just move on. What I was trying to explain. So for each works on each element inside an array. So one area where higher order functions shine is data processing. To process data, you need some actual data. So this chapter will use a data set about scripts. That is writing systems such as Latin, Cyrillic, or Arabic. So that is what we are going to be looking at. This system apps, like Unicode now, the system that assigns a number to each character. Well, most of those characters are associated with a specific script. So the example data set contains some pieces of information about the 140 scripts defined in Unicode. If we go to So this is an example of the code we'll be looking at of higher order functions. So in the context of chapter 5, you now see these test scripts. This test script takes a function, an argument of text. So you now see script is, you now call the count by function that counts text and char. This text is the parameter you pass, the input you pass to the function. Then char is the higher order function that runs on this count by. So that one now says for each script, get the code point at 0. So this gets the actual code points for each letter. So if it doesn't have a letter, if it has a letter, you return the script name, else it returns what? None. So you now filter all the characters that don't have that don't have a name. So basically, that is what we are going to that is how higher order functions work. So these are the objects now. So such an object tells us the name of the script, in this case, which is what? Coptic. Which is Coptic. So Coptic is like a type of alphabet. Coptic is like a type of lettering system that they use to denote letters. Is there any question so far? I'll take silence as no. Is there any question so far? I'll take silence as no. Okay. So we are going to look at filtering arrays. So when you are filtering an array, you are filtering elements that don't meet a certain condition. Let me say for the students in the class, I want to filter out anybody that is not in secondary school. So I'll now be like, if you are in secondary school, you will remain in the array, else you go. And basically, we can use a for loop, then passwords and if statements. So we'll now test the elements. If it passes the test, we now push it to the passed array and return the passed array. But that one is a little bit complex, so we can use the higher order filter function, where we say scripts the filter for every element such that the element's direction is equals to what? TTB. So probably for this filter now, we can now have an array of elements. There's the so let me say this thing. Let me share my screen. I hope filter will be working though. So I'm saying for each node. And you can see for each working now, it prints every element. So if I say I want to do filter now, and I have an array 1, 2, 3, 4, 5, then I say dot filter. So I want to filter every element. So I'll say lm. So I'll now say lm such that if lm is an even number, then I'll just console.log this. So I want to filter this array to get only even numbers. And that gives me what? That should give me 2 and 4. So this is the array. This is the array. Then I'll filter every element. So the first argument here is the element. Then second argument is now the callback function. This is the function that gets called. So filter is a function taking in another function. This is the function here. So filter, you give a test. You give a test and you watch it this thing. And you get all the elements that pass the test. Who is even here, self? Obina, are you with us here?
I'm here.
What will this code give us? I've changed this code now. What will it give us? What will be the
1,
return?
3, and 5.
1, 3, and 5. Why is it 1, 3, and 5?
Because they are not even numbers.
Okay, and that was the function here. Let me say I write. What will this give us?
Just 2.
Just 2. The test is elements that are greater than 2.
Oh, then that's 3, 4, and 5.
Thank you. So filtering is quite simple. You have your array, you write dot filter, you have element, you now write the callback function with arrow sign equals to, then greater than sign. Then you now write the test you want it to what? Pass. So to transform elements from one form to another, we use the dot map function. We use the dot map function. So that is to take a set of elements and take them from what? One phase to what? Another. From a 4 state to a 2 state. Let's say you have an array. You have an array of elements, 1, 2, 3, 4, 5, and you want to multiply every element by what? 2. So I'll show you the old way, then I'll show you the new way. So if I share my screen now. So the old way, I'll write a function now. I'll now call it what? Multiply by 2. That'll take an array of numbers. Then I'll now say what? For I is equals to 0. I'll now loop through the array. I is less than a dot length. I plus plus. I'll now loop through the array. I'll now say what? A of I is equals to what? A of I times 2. Is everybody here? A of I is equals to A of I times 2. Then I'll now be like console.log A. Then by the time I now call multiply by 2 on an array of elements, let's say 2, 7, 8. And I run it on the console. It gives me what? 4. 2 times 2 is what? 4. 2 times 7 is what? 14. 2 times 8 is what? 16. So I transform every element by multiplying it by what? 2. But this way is, as we said, we want to write it in as little lines of code as what possible. So we have the same array now. But instead of writing all that, we just say dot map. And dot map takes 2 values. First, it takes the value and the key. The value is each individual element. The key is the position of each individual element. we now say such that what value times 2. Then we log that to the console. And note how we do all that in one line. And by the time we do that, we get the same answer. We get the same what? Answer 4, 14, and what? 16. Because we have changed each element such that each element gets multiplied by 2. That's how you do it. So we have spoken about for each, we have spoken about what? Map. We have spoken about what? Filter. So we have another. We have another function for summarizing called reduce. So another common thing to do with arrays is to compute a single value from them. That is summing a collection of numbers. You can imagine doing that with a for loop. That one is too long. Or finding a script with the most characters. So the higher order operation that represents this pattern, when you have an array and you want to get a single value from them, it's called the reduce. Or sometimes it's called the what? Fold. It builds up a value by repeatedly taking a single element from the array and combining it with the current value. So the parameters to reduce are the actual array, then a combining function and the starting points. So we look at this reduce element. So you have the array, the combining value, and the starting point. So you now say let current equals to what? Start. So we are starting at the current. Our current to be the start. Then for each element in the array, we'll now say current will now combine the current and then every element. So you can imagine current starts at what? 0. Current starts at 0. Then for each element array, we'll keep adding it. So from 0, 0 is this first element here. Then we'll now add it to the next one. Combine, which will now give us what? 2. We'll now add it to the next one. 1 plus 2 will now give us what? 3. 3 plus 3 will now give us what? 6. 6 plus 4 will now give us what? 10. So this is the reduce function. So you can see it to take the starting value and the total value or the resulting value and to add both of them together. So to find the script with the most characters, you now say script.reduce a, b such that you return the character count of a if it's less than the character count of what b. So by the time it checks this character count, checks this character count. If this one is less than this one will now move on to the next one until it finds the next character count. If A is less than B, you return B. Else, if B is less than A, you return what? A. Remember these ternary operators. So composability. So composability simply means that the way you write your code. And what this chapter is trying to, this portion is trying to say is that higher order functions help you to compose your code more succinctly. Your code becomes easier to write and easier to what? Read. So higher order functions start to shine when you need to compose operations. For example, you write code that finds the average year of origin for a living and the death script in the. So you want to find average now. So by the time you reduce the array, find the sum of all the elements in the array, you now divide it by the length of the array. So to see if you guys are really doing it, I'd like somebody to volunteer to share their screen. One person. Who is this PC person? This person that signed in as PC. Anybody who feels like they are up to the task. I
don't have light here. My PC is off.
Deborah, how about you? Or Ayo? Can you share your screen? Let me stop sharing mine.
My PC is
Let me
off.
ask you some
I don't have light
questions.
here.
See, between. Okay, you don't have lights.
Yes, sir.
Deborah, how about you? Obina, how about you? Nobody is up. Nathan, how about you? Nobody. Okay, now let's continue. So strings and character codes. So one use of the data set to be figuring out what a script in a piece of text is using. What script a piece of text is using. So you now see a script where each array, each script has an array of character codes associated with it. So you now say for each code now, for each script in the code, the range, we should return the range of each code. So if we now run the script on the code of 121, you now see 121 is in what? Latin. Probably 100 could be in another character's code. So I'm going to take a function now. We are going to use a reduce method in combination with the concat method to flatten an array. So how a nested array looks like, you have an array, then you have other arrays inside an array. So let's say this is 1, 2, 3. Then we now see another array, 4, 5, 6, and another array, 7, 8, 9. And the task now, let's say this is the nested array. So let's nested equals this. A nested array is an array that has other arrays inside it. So a common task is to flatten an array using the what? Reduce operator. So yeah, you can use reduce operator. So what that will now do is that you will now say flat array now. So you now say let flat equals to nested dot reduce. So for the accumulator and each value, the accumulator is the result we are going to return at the end of the day. The value is the individual value we are working with at each point in time. We now say we'll return the accumulator, concatenating it with its value. So in the accumulator in this case can start with this first array, then to now concat it with it will now concat each element with each array. So it starts with this first array. Then for this 4, 5, 6, it will now take each element in this 4, 5, 6 and add it. So it now gives 1, 2, 3, 4, 5, 6 instead of this nested array. Then by the time we are done, we now add an array at the back to say that is the array we want to return. So you should concat it. And this nested array here tells us that this accumulator, we want it to be an array. So we return an array at the end of the day. So if we now console.log flat, we see that we get a flattened version of the array. So that now flattens the array. So the next So the next exercise we are going to be doing is creating a function. We are going to be creating a function now that only works on filtered values. So we are going to say for an array now, let me see, let R equals to 3, 4, 1, 2, 5, 7, 8, 9. So we are going to take a function, write a function that only that filters out all the odd numbers, then multiplies them by 4. So it filters out all the even numbers, and multiplies them by 4. So we'll now say console.log so that it will show this to the console. And we say r.filter. We want all the even numbers. lm such that lm is an even number. Then we now map this thing such that for each element, note that higher order functions can be what? Chained. You can see how we wrote this dot filter. This now returns its own array. Then we now pass that to what? Dot map. So for each element, we now multiply each element by what? 4. So we now see got all the even numbers, 4, 4, and 8 in this portion, and multiply them by 4. So 4 times 4 now give what? 16. 4 times 4 again gave 16. 8 times 4 gave 32. So another common task you'll be doing is working with the for each method. So let's keep this array. So you now say let new R. So for each method works like the for loop, but is much more better because it does everything at once. So for each element, so we can use for each like a map. So for each element, we can now still say element multiplied by 4. And here it works like a map. So we'll now say for each. So R for each. You now pass the function you want to happen for each element. Where you say for each element, you want to multiply each element by 2. So this is the function we want to apply. Then we now say for each, we'll now say multiply 2. And that now gives us each element.
Are you serious? No. Ah! Are you trying to escape it?
So that's it about higher order functions. You have map we have for each that works on each individual element. So you now pass a function like multiply 2 inside each to work on each array element. Then you have another function, filter, which filters out a list of elements based on a particular condition. Then you now have another higher order function called map that transforms each individual element, taking them from one point to another, probably adding them by 2, multiplying them by 2. Then finally, you have the reduce that returns a cumulative value based on a particular function. Yeah, so that's that about that. So briefly, I'm going to introduce objects and how they work behind the scenes. So a concept you must understand about object-oriented programming is encapsulation. So encapsulation is to divide into smaller pieces and make each piece responsible for managing its own state. Another piece of code should not manage a different state. So a page should not manage the data for another page. That is the point I'm trying to make. So that way, the knowledge about a piece of a program is kept local to that piece. So everybody is responsible for the data every component is responsible for the data it works with. So different pieces of programs interact with each other through interface, and an interface is a set of functionality that provides an interface is a set of functions that you can use without having to know their precise implementation. So let's say you have two objects. One has a function to cook. Another one has the function to what? Clean. So one object requires food. So he goes to the cooking object and asks for him to call his cook function. He doesn't need to know how that cook function is implemented. All he knows is that he wants to see what? Food on the table. The same way that cook object now wants a clean room. Then he goes to what? The clean function, the clean method, and asks him to what? Clean the room. He doesn't know how he wants the room to be cleaned. All he knows is that he wants the room to be what? Cleaned. So that internal implementation detail, that precise implementation is this thing. Is the way information can be hidden, but you can still use the functionality. So such program pieces are modeled using what? Objects. So an object has an interface that consists of certain methods and what? Properties. Properties that are part of the interface are called public. These public properties can be accessed from other parts of the code. So the other properties which are not available to the other properties that are not available to every object are called what? Private. So you have to understand which properties are what? Public, which one are what? Private. For example, your API keys Your password will be in what? Private keys. But something like your full name can be in a public key in the interface. The interface only is that it takes a contract of the functionality is meant to implement, and it extends that, and it works and it fulfills that contract in the sense that anybody that accesses it to do something, it will now do it. It's just like the way you hold a remote. The remote is a what? Is an interface. You don't need to know how the remote was constructed. Before you know what, you press a button and the TV turns on. You press another button and you're able to what? Change a channel. That is how interfaces work. You just borrow the functionality, but you don't have to know how it was implemented or how it was built from the ground up. So methods are object properties that hold function values. So you have an object like this, then you give it a function name. Let's see this in VS Code. So here we have an object. Then we now define a property of that object, rabbit, called what? Speaking. Let's say if the rabbit could talk, this will now be part of the rabbit's behavior, where it now accepts a function that says a particular line. So if we now say rabbit.speak, I am alive, the now shows what? The rabbit says what? I am alive. The user doesn't need to know how this speak function is implemented. He just needs to know that he can use it. Interfaces are particularly important in places where this level of security needed is very high. Like a bank now, you're at your ATM, you're using the interface. Maybe your transaction is represented as an object. Let's transaction equals to an object. Then you now say transaction.send will now be to send a certain amount of money. Let's say we want to send money at the ATM from one point to another. We will now say what? This is total. Total equals to, and your balance. Let's say your balance is 1,000 naira. They now define a functionality that when you send the money, it should reduce your balance by what? The certain amount of money. Then it should now console.log your exact balance. So it will now be like your balance is balance. So by the time we call transaction.send of maybe 200, So is there any questions so far about the class?
Sorry, in this piece of code you wrote, what is that this dot balance?
This is a keyword that refers to the property inside the particular object. In this case now, are you getting? So this
Yes.
now refers to this thing. This is a confusing keyword, but it's used to refer to the current context. Are you getting me?
Yes.
Of the particular object. It's something we'll cover later on. Any other question? In the absence of questions, I wish you all a wonderful day.